a batch of cylindrical metal cans are to be manufactured. They are each to be filled with 6 liters of juice and sealed. What is the minimum amount of metal that can be used to manufacture them? So this is an example. We're going to use differentiation, and it's Maxima and Minima. We're finding minimum values here. All right. In our previous video, we found the maximum volume of a container, right, when we have fixed amount of sheet metal. Now here, the volume is already fixed, but we don't want to waste sheet metal and thus waste money. So we want to find out the minimum amount of metal that can be used to manufacture these cans. All right, so here now, we have the cans. They are cylindrical, so let's say we have these as our cylinder. All right. Well, this is not drawn properly. Let me redraw this part of it. Well, still not perfect, but anyway, you get the idea. So we have to make 3 main parts and fit them together. There's the top, there's the bottom, and the side. If we consider the sides of this container and we cut it open, right, we would have something like this if we don't fold it completely. You know, this side of a container. Now, the top, what is the area? The area is equal to, what is a circle? So the area is pi r squared. What's the area of the bottom? The area is also pi r squared. R will be the radius, right? So you have to remember that the area of a circle is pi r squared. What about the side? So here now, we have the height, call it h. But the length here is the circumference, which will be 2 pi r, alright? Remember that? Circumference of a circle is 2 pi r. So when you cut this, cut it here and spread it out, from here to here will be the 2 pi r. And you have the height h. Alright? So, in this case, the total surface area, call it SA, would be pi r squared plus pi r squared, which means 2 pi r squared plus, then you have the area of the side, which would be 2 pi r, that's the length, times the height, which is h. So it's plus 2 pi r h. Alright? So that's what you have. But the thing is, we have 2 unknowns here. We have r is unknown and h is unknown. So how do we mix this up so that we have only 1 unknown? Alright, we know the volume, 6 liters. But 6 liters is equal to 6,000 centimeter cube, right? 6,000 cubic centimeter. So let us make the measurements in centimeter so that the radius will be in centimeter. The volume is, what's the volume of a cylinder? Is pi r squared h. And the volume is 6,000. So it's 6,000 centimeter cube is equal to pi r squared h. Alright? When you transpose this, h will be equal to what? 6,000 over pi r squared. Alright? 6,000 over pi r squared. So, you could put this there. The surface area would be 2 pi r squared. Because remember, you know, when we say amount of sheet metal, we're talking about the area of the sheet metal. You're not going to shave down the side to make it thinner. Alright? You have a certain thickness. But right now, we're not trying to control the thickness. If it is too thin, then it will be easily punctured. If it is too thick, it's heavier, which means more costly to transport, and you have more metal for a thicker can, which means more money than necessary wasted. Alright? Or more money than necessary would be spent. So we have a set thickness. What you want to minimize is the surface area. So 2 pi r squared plus 2 pi r times height, which will be 6,000 over pi r squared. We can simplify this. 2 pi r squared plus r into r one time r into r squared goes r. 2 into 2, 1, 2 into 6,000 is 3,000. So we have 3,000 over, no, hold on, pi cancel pi. So r into r1, r into r squared was r times. So what happened here? The 2 cancel, so that's gone. It's 3,000 over r squared. Cancel, the pi is cancelled. So it's r. 3,000 over r. Alright? So, what we have is that the surface area is equal to 2 pi r squared plus 3,000 over r. Alright? Now, the surface area, it will vary. But we want to identify a local minimum point, or a minimum point, right? Now, we're going to have to differentiate this. Well, let's write it in this format first. 2 pi r squared plus 3,000 r to the negative 1. Right? So, d surface area by dr is equal to, it's going to be 2 times 2, which is 4 pi r, because it's 2 minus 1, which is 1, r to the 1 is r. Alright, plus negative 1 times 3,000. So it's negative 3,000 r to the negative 1 minus 1, which means r to the negative 2. Right? So you see that? So, in this case, what we have is at the minimum or maximum point, it is 0. So what we can say is 4 pi r minus 3,000, we can write this as over r squared is equal to 0. Alright? Now, we can add the r squared to both sides and say 4 pi r is equal to 3,000 over r squared. We add the 3,000 over r squared to both sides. Suppose we multiply by r squared. would have 4 pi times r cubed equal 3000. This would imply that r cubed is equal to 3000 over 4 pi. Right? I'll write it like this. 3000 over 4 pi. So that is r cubed. Let me simplify this. R cubed is equal to, we say 4, 8 is 32. Alright, 4 into 4, 1. 4 into 30. 4, 8 is 32. 4, 7 is 28. Goes 7. Leaving 2. 4 into 20. 4 into 20 goes 5. 750. Alright? So, it's 750. 750 over pi. So r is going to be the cube root of 750 over pi. What is the cube root of 750 over pi? Let us see. All right. So, all right, let's do it this way. The cube root is the same as, all right, there's no cube root function here, but we could raise it to the power of 1/3. Right? So open bracket. 750 over, where is pi? Over pi, close bracket, raised to the power of, open bracket, 1 over 3, close bracket, equal 6.204. So it's 6.204, right? 6.204 centimeters we have. That would be the r, the radius, right? That would be the radius. Now that we have the radius, we want the height. So 6000 is pi r squared h. So 6000 is equal to, we can find the height now, you know. Pi times 6.204 squared times height. So therefore height is equal to 6000 over pi by 6.204 squared. So what is it? Let us see. So what we have here, pi times 6.204 squared is equal to that. Then 6000 over that, 49.62. 49.62. All right. So what is the total surface area that we would get now? Let us see. The surface area would be 2 pi r squared plus 2 pi r h. It's 2 pi r squared plus 2 pi r h. So it's 2 pi times 6.204 squared plus 2 pi 6.204 times 49.62. So the surface area that would yield the amount of metal in terms of surface area would be. Let's see. Let us see. It would be 2 pi by 6.204 squared equal that. Oh, malformed. Oh, times. I should put multiplied by. Alright. Let's just do all of it in one, plus 2 times pi times 6.204 times 49.62 equal 2176, around 2176, 2176 centimeters square. That would be just about the amount of surface area. So we have a radius of 6.204 centimeter and a height of 49.62 centimeters.